application of GIS. So the topic will be GIS applications in planning and optimization of water distribution pipelines. So if water resources, specific water resources students are not there, then it will be tough to understand what is actually water distribution network. So I'll give you a brief overview of what is a water distribution network. So basically, this work will be focused on water distribution network, means the supply of water, which comes to you from municipality. After the water treatment plant, means from the reservoir can be groundwater, can be surface water. So we will pump the water from the reservoir and will store it in the water treatment plant. Then we'll do minimum processing, like we'll put chlorine, okay, like we put chlorine as disinfectant in swimming pools. Similar to that, we'll put just a pinch of chlorine to gallons of water, which is in ppm, and those chlorine amount are considered as disinfectant. So once water will be disinfectant or all the microbial organisms free, we do not go for any other kind of chemical process, and we supply it to customer, means to you, to your houses. Water is going from reservoir to water treatment plant, then to municipality, then to the overhead tanks in your nearby areas like in park area, and it is going to your house finally. So that is a whole water distribution network, or you can say whole water infrastructure. But all those water infrastructure earlier in conventional way is actually like physically people were water distribution infrastructure were planned like people will go to the field just like you do surveying, mapping kind of thing. So they will do the whole map, and then they point where there will be junctions, where there will be nodes, and they will be designing the water distribution network. Still today also in few areas of India, we follow the conventional water distribution network and we do it conventional way. But we have examples of smart water distribution systems also, which is highly integrated with GIS nowadays. So your GIS, as you know, is geographic information system, or you can say geographical information system, is highly linked with the satellite data. So now we are trying to make the whole distribution system, the water which is coming to you, in a smarter way, and we are now integrating it with GIS for real-time data fetching or real-time data storing. So for which actually before going into the GIS platform, you need to understand that what actually we are focusing for. So we are focusing for an efficient water supply or water distribution to the people. Then the whole energy what will be utilized in this, like pumping system you will be utilizing, so you will be having electrical energy into it. So we need to optimize the electrical energy use, means we have to literally minimize its use here. So for that also GIS is helping. In addition to that, the bigger part in this is non-revenue water, like leaking, like any unauthorized connection, any unbilled connection. So to detect all this, again, GIS is highly helping us to fetch the data, real-time data, and to act upon it. Okay, so that is a overall view of water distribution network if you are new to the field. So very interesting. Uh, so now I'll come to the conventional planning of water distribution network, which I think already I have discussed with you. But still, when we had this conventional water distribution network, which is now also present in some remote areas and also in few towns, okay, mostly in smart cities, we are going to smart distribution system. But still in few towns and few rural areas, we are following the conventional distribution system where we do not have the integration of GIS. So we have to go to the field manually. We'll align the points. So these will be points. These will be the consumer points. This will be the tank points. This particular area will be pumping station, and then we go for the water distribution network infrastructure setting. But those infrastructure setting cannot be again real-time basis. We cannot collect the data and we cannot go instantaneously to that area to checking or to any kind of renovation. If it is conventional, again those if at one point water is leaking or some renovation will go, that particular whole area will be closed. There's no water supply to that particular area, so that is very tough. And that is happening also in few areas. But we will not focus the conventional part, we will focus more on GIS and the new smart water distribution system, or you can say integrated water distribution system along with GIS. So, a role of GIS will be here to integrate the spatial data. Spatial data means space data, okay, places data. So, I'll be little bit going into the definition form because I have seen various students are here. So, spatial data means places to places, varying from place to place. So, when I say varying from place to place, which is the main role of GIS to find the elevations, okay, to draw the contour map, to find the land use, land cover, which area is industries, which area is urban, which area is barren lands. So all of these are the basic information we require from the GIS, which again we fetch from satellite. So we have various types of satellite, like you have a satellite named as GRACE, which is giving us the meteorological information or meteorological data. Similarly, we have various satellites which will be fetching the spatial data, place to place data, land data, and giving us. So we do not need to go to the field first. Okay, so our manual labor is done. We are not going to the field. In addition to that, we will be fetching the real time data every time whenever we will be going for any leakage detection, any kind of renovation, anything. In addition to that, route optimization is very, very important. Which route means, like if you are in the transportation field, you know you find the route through the GPS system, like the road network. So GPS is again geo positioning system, so mostly focused on road network. Similarly, here in GPS, we will do the route optimization, but it is not integrated to GPS. We do not need GPS actually. We will focus on GIS and we will go to the raster mapping, that is known as rasterization of the layers. So when we do the rasterization of the layers, we will find the points and also various attributes in the form of it's a road network, it's a catchment area, it's a industry area. So accordingly we will find the route so that our water pipelines will go. So it is again highly similar to your transportation work also, if you are from the transportation, because your water pipelines will go below the roads only. Whether it is sewer pipelines or water pipelines, it goes below the roads only. So first we lay the sewer pipelines, okay, where your dirty water from your home will come, okay, come out, and above it we will lay our water pipelines which will be going into your house. So your sewer pipelines have larger diameter, okay. So if you take 20 inches diameter of your sewer pipeline, your water pipelines will be approximately 6 inches, 50% lesser than that, because we are maintaining pressure inside the water pipelines. When you open the tap, you will say, okay, my pressure is fine. Okay, some days if you find okay, water is flowing very slowly, you'll say my pressure is low. So that pressure actually, which a layman says, actually water pressure which we maintain inside the pipeline, and that is also we are fetching the data from the GIS only. So route optimization and also pressure maintenance, pressure optimization also done in GIS. So I'll go to the software also and will briefly show you how we do it. Okay, so do not worry. We need to understand the basic fundamental thing behind this first. In addition to that, we also do the demand mapping. Demand means your demand, how much water you need. In India, we having an urban and water. Like you, if you heard about the various projects, various schemes by government, we have a Jal Jeevan Mission. Okay, JJM. In Jal Jeevan Mission, we focus on the rural area. So where we need to supply, if we follow Jal Jeevan Mission, which is being followed in India very rigorously. So if you follow Jal Jeevan Mission, then we will be supplying 55 LPCD of water per day. You will not believe, only 55 LPCD, 55 liters per capita per day. So if you are 5 members in your home, then 55 multiplied into 5 liter of water we will be supplying. That is minimum. Okay, that we are going to supply obviously. Then if we have more water, water will be going to your home continuously or intermittently. Like right now I am in Jalandhar, and as I belong to urban area, Amrut is being followed here. Okay, so Amrut is again another scheme by the government, which is again focused on urban areas. Okay, so in urban areas, we'll be supplying 135 liter per capita per day. So if in my house we are a member of three, so 3 multiplied into 135 liter of water will be coming to my home anyway. Okay, but the challenge is government is actually municipality is supplying much more than those particular amount which is as per the Amrut or as per your CPHEEO, which is Center for Public Health and Environmental Engineering Organizations, which mostly decides how much water we are going to give to the customers or you people, consumers. So CPHEU, which is the main organization under your Ministry of Environment, which is dealing with how much water we are going to supply, and that is 135 liter per capita per day to the urban areas. But government is supplying much more than to us in terms of intermittent supply, like I know I'm in Jalandhar and to my home 2 times water comes and evening 5 to 8 approximately, and they supply like any volume of water you want to store, you will be storing it. So that is much more than 135 liter per capita per day. And that is again following the conventional way of supply. So our main aim is to integrate everything with GIS and supply the water 24/7, check all the water losses, take all their demands and supply accordingly so that we will be saving the natural resource also, and we will be taking the revenue according to your use also. Like right now in India, we will be taking the revenue as a fixed revenue, and that particular revenue which we are taking is not actually how much water you are using. We are taking that revenue to do any kind of renovation in the water infrastructure. We are not taking the revenue of the amount of water or the volume of water actually you are using. So if we integrate it with the GIS, which is again not completely new and not done in India, yes, these are already implemented in India in few parts. So I'll go there also. So demand mapping can also be done, like I have given you the examples of demand and what is your demand. Demand means your demand of water. If I go vividly, very descriptively into the demand, your demand again varies. Like during the night time, you do not use water, so your demand literally zero, isn't it? Or a little bit, okay, 100 liter per person. If I consider that, it will be more than enough. Similarly, during the morning time when you wake up and will be ready for the university or to any other workplace, you require a lot of water at that time. You will go for bath, you will go for cooking or any other kind of work. So at that time you require more water. So my aim is to give you water, or the government aims is to give you water whenever it requires. So we will be supplying you 24/7 water, and whenever water you require more, water will go to your tap or you are using it. So that is what again not possible if we do not integrate GIS into it. That is what demand mapping we do, again through the satellite data. Similarly, infrastructure monitoring will come when you are going for any kind of leakage detection, any kind of valve you are going to fit into it, any kind of new extension you are going to take because a new area is set up there. So all type of infrastructure monitoring can also be done through GIS. Okay. So if we go into GIS, then what is actually basic fundamental things we require? We will require digital elevation model. If I go into digital elevation model, you require a lot of data into the model. Okay, again, as per requirement only. So like in the figure B you are seeing here, you require built up area, you require forest vegetation area, you require the open field, okay, or agricultural lands like paddy field I have taken. So I have taken an area of a different country, so you cannot correlate with India. So similarly, you can take water bodies present there, and this is one map for a digital elevation model. Several layers you require. So inside several layers, those are also known as attributes. So different layers will require inside different layers. Again, few examples I'll give which kind of layers will be. It can be a soil type layer, it can be a land use, land cover layer, which kind of land you It can be a population density layer, it can be a road network layer. So whatever layers you are seeing here will come finally integrated into the DEM, and your final DEM will be ready with all those data. So you are seeing only here land use land cover map. Okay, a random map which is on your A side, which is the boundary and legends are not reflected, but still it is showing the land use land cover. But B is very clear, showing you the land use land cover means how much area is covered with which land. So this can be done again. So if you are expert in GIS, you know we have grading patterns. We can separate the area and we can calculate the area explicitly, precisely, and we will be going for our next level of uh, analysis. So all this data I require whenever I go for a optimized water distribution network in GIS. So mostly we use ArcGIS, then we take the data to various distribution network models, or I can say interface. So I'll show you those interface. Okay, ArcGIS, many of you know. Similar to ArcGIS, we have QGIS, we have GrassGIS, in which you can fetch the satellite-based data. And various sites like USGS, okay, ISRO, from there also you can take those attribute data. Those are also freely available. Most of the GIS data nowadays are freely available. Now coming to pipeline route plan, which I have said you, and for that again, when you go to put the route, like you're going to put the pipelines, you will design the route. You need to understand which type of soil is there so that you will excavate, no, and you need to understand which kind of terrain in that particular area. Means obviously Himachal people, those who are having tenants throughout, are also having pipeline water supply only. Okay, they do not have much wells or tube wells or something like other source from the lakes or streams. So they are also having the water pipeline system over there. So we need to analyze which type of soil is there so that we will excavate the soil without disturbing the aquifers inside it, without disturbing much soil layer inside it, so that we'll be able to supply our pipelines, or we will route our pipelines. So for that also again we will take the help of GIS. Okay, so like you are seeing the maps here. Here you will be seeing mostly the essay between these are your elevations, higher elevations. So these are terrain area, means hilly area. On the sides which you are seeing are valley area. So accordingly you will be designing so that optimized water supply will be there. So if your tank is at the hill area, like tank means you are storing water from a stream of water and you think it's the best possible source to supply water, your head top tank will be at the hill and you will be supplying water to the valley area. And you know that is the best optimized minimum capital cost investment kind of design, which is not possible in the plain land. Okay, so if we go for route planning through GIS, like in the second map also you are seeing, those are all the routes for the water pipeline distribution, or you can say those are roads, because below the roads only we will lay our water pipelines. So it's good that we can integrate the transport routes along with our water pipeline transportation. So we can integrate the two also simultaneously. Similarly, your pipeline should not go near to a railway station or below the railway track, or the roads where heavy trucks or heavy vehicles move, because chances of busting will be there. So all those can be again you can detect through GIS, mostly by studying the elevation. And if you require any kind of heavy motor, heavy vehicle data, railway data, then also you will go for transportation or traffic data analysis. So you can also analyze the traffic data in GIS. At the end of the day, we will be having our multi-criteria decision analysis. Means you have collected a lot of parameters, now you are ready to integrate it, and you will do it through weighted overlay. Weighted overlay means again, like I've said, you have these data: population, land use, land cover, pipeline, soil type. Now you will decide which layer is more important to you, and those data's weightage will be high. So those will be at the top. Okay, so for us, our main criteria is placing of your houses. Okay, first we check which place your houses are there. So that is what elevation. Okay, so how much elevated area or plain area as per the mean sea level, we check the elevation. So for us, our overlay is elevation data. So we'll take first the elevation data. So my weightage of elevation data is much more than the any other data, and I'll arrange it according to it, and I'll go into the next planning of it. So here also you are seeing a map which is again integration of GIS with a software, mostly it is IPANET. Okay, so I will show you the IPANET software. So where we integrate the hydraulic systems inside the GIS. Again, hydraulic systems, if you ask me, what is hydraulic system in GIS? Because you know when you work in GIS, you need to be expert in various field. Okay, not much in structure, but you have to be expert in various other field, like few parts of soil you have to study, few courses specifically if you are a student, then few parts of your water distribution network you have to study. Okay, climate part, environmental part, not the overall degree you require, but you have to understand and you have to implement it along with GIS. So you need you know, precise knowledge, very, very precise knowledge. So here what we do, we require few knowledge, few data of water also. So that is hydraulic modeling. So in hydraulic modeling, again, we need to understand how much water pressure you require, so that water will be reaching to your house, coming out of your tap, and should not burst our pipelines also. So for that, we need to check the pressure at different points, and we have to maintain the pressure. We have to optimize the pressure. It should not be minimum. It should not be maximum. So you have to follow the pressure part much. In addition to that, if it will not flow, volume should be perfect. If it will not flow properly, means velocity should be perfect. If is there any kind of sedimentation or if any kind of precipitation happens, that means yes, friction factor, so which you heard about earlier. So friction factor is also focused here, because if there will be friction, you know, energy will be reduced. Which energy? Again, water energy, energy inside the water. So water is moving along with a momentum inside it. So if momentum will be reduced, then obviously velocity will be low, and ultimately you are not getting the water with that much pressure which you require. So if you are going to bath, your class is at 9 and you are waiting for water and it's coming out very slowly, that means you have low pressure inside it, low velocity inside it, and the amount of volume it should be inside the pipe is not there. So those again we do the integration through GIS. Again, not only GIS, by putting the sensors in terms of pressure sensors inside your pipelines, mostly to the critical points where the pressure is very low, and we check here our pressure. So if I am a administrator and I am the admin of taking the whole system, then I am having a SCADA system, which is your supervisory control and data acquisition system. So I'm sitting here and I'm seeing at which house pressure is low at this time, and accordingly I'll modulate, change it. Okay, do not worry, this system is going to be implemented very soon in India, because again water is considered as a natural source, and as you know, we have very, very less drinking water. Okay, and 70% are filled with saline water, and in India mostly we do not go for desalination procedures, so we have very less amount of drinking water. So we're going to implement it very soon, and few areas already implemented. So we analyze the pressure zone through GIS. In addition to that, pipe diameter optimization. Here, as I say, pipe diameter will be again, when we install it, pipe diameter is perfect. Now, whether we are installing 6-inch pipe, 12-inch pipe, or any inches pipe, again, in water distribution system, various sizes of pipes are being used, mostly in smart cities. Like we have Chandigarh, which is highly planned city in Punjab, and we follow a very beautiful water distribution network here, fully optimized. So different diameters of pipes are required, and inside that we require different pressure and different sedimentation rate also. So all those can also be integrated with GIS, but we need sensors on the backside of it. Similarly, pump scheduling also we can improve, but not highly integrated with the GIS. It will be integrated with AI or ML, your machine learning technique. So in machine learning, again, we will put a loop kind of system, and at this particular time, automatically your pump will switch on, and once your tank is filled, there will be a alarm system coming to the pumping part or your pump house, and it will be switched on. So again, that can be integrated with machine learning, very less integrated with GIS. That's not actually our part in GIS, but very important. Then storage tank, which I have said, overhead tanks are placed in hilly area, in at a top, and in your area inside your parks, near to the parks. If you have parks near to area, obviously there will be a water tank inside it. Similarly, fire flow requirement analysis also we do for any kind of fire hazard, and that is again not included inside your daily water distribution network. That is a separate calculation we do, but we integrate with GIS. Now coming to the models which actually we use in GIS, as I say, IPANET is a very common tool which we use, and that is given by US EPA. And IPANET is your environmental protection network, okay? Environmental Protection Agencies network. So EPA is Environmental Protection Agency, and this IPANET is an Environmental Protection Agency network. And we have a very small interface in IPANET which is highly useful, okay, in few parts of L&Ts and also in various organizations, those who work with water distribution network models, they use IPANET, which is freely available, open source. You can use if you are a BTech student, and if you're interested in water, your project uh, can be based on IPANET, which is highly easy and very informative, and paper publication is very easy in this field because it will be real time analysis. Similarly, water James, which is given by Bentley. Okay, so you have to buy it little bit costlier. So I'll not suggest you to go for water James. But if you have Bentley workshop, like in many university, you have Bentley systems. So if you have Bentley, then water James software is free with you. So if faculty,
Yes, madam. May I just interrupt for a minute? We do have collaborated with Bentley and we have these softwares available just for the information of students.
yes,
So
yes,
thank
that's
you
what
for
I was.
pointing that out. Yes.
Yeah, I was saying the same, that if you have Bentley Live, that is a free software comes with Bentley.
Yes, yes, yes.
Yeah.
We do have
So,
that. Thank you, thank you.
yes.
Please continue.
So these water gems actually students those who are here and want to pursue their project in water distribution network. Like you have many students, I am very much sure 80% students those who are here will never heard about water distribution system, which is a very important part nowadays. Like you are seeing this present situation, we don't have LPG gases, petrol prices are hiking. Similarly, in the upcoming time, water will be a also very important natural resource going to happen, and for that, to conserve water, we need to go for a proper water distribution system and a real time data fetching. We are not going to give you unnecessary water, okay, unbilled water. So those will be, again, we are going to check in, we are going to bill it, even if not like petrol price, but again we will bill it in terms of a metering technique. So right now also in India also it is implemented in few part. Like I have said, I'll take one example of Nagpur. If you have water gems, then madam, you must give the permissions to students to register their account, and they should work in water gems, which is now I have attended various meetings and various conferences where this particular water distribution network is now in a top research part. Means various people are focusing on water distribution infrastructure nowadays.
Right, right. Yes, we have just now signed a MOU with them. So now I'm thinking of we will be arranging some session through them
Yes, ma'am.
itself. They are ready to come, some of them,
Yeah.
to sort of give a training 1 or 2 days. So that is in process.
Yes,
Yeah, we'll surely
So
do
we
that.
have
Thank you.
also, yeah, we have also this Bentley, and many of my students are working in water gyms. So few network I have from IPANET, okay, and few from water gyms, which is under construction. Few network of IPANET I'll play and I'll let you know. Those who will be new to water distribution network, I'll suggest first you play with IPANET. Like, it's a very small interface and very highly useful. It's not like you'll make a IPANET network and it cannot be implemented in the real field. It is 100% implemented, possible to implement the IPANET network in the field. But IPANET you will learn within 7 days. So, madam, I will suggest you, before you install water gym, you just make a small workshop for 2 to 3 days for IPANET, which will make the student curious about learning, and then make them integrate with GIS and water gems, which will be highly fruitful. Um,
Sure, sure, we'll do that. Thanks for the suggestion.
Yes, ma'am. So I'll show you the Ipanit part also here. So right now, and Water James is not in my laptop. If you later on will plan something, I'll show you the Water James models also.
Wow, that would be nice.
Uh,
Thank you.
Okay, ma'am. So, as I say, leakage detection and NRW, non-revenue water loss reduction, will be very important for us when you go for smart water distribution network. So, here you are seeing a particular area, there is leakage or any kind of pipe bursting. So, why this pipe burst? If you have taken the water pipelines through the road network and heavy vehicles travel, like in India, we do not have the specific rules, and even if we have rules, the truck drivers and those deals with cargos, they do not follow those rules to how much amount of things or weight of particular material they are going to take on the truck, so they exceeds it. So when they exceed it, mostly what happens, water pipeline burst if it is larger size. So what we need to follow, again, the water pipeline should be smaller in size. We need to focus. So if it is by chance large, because you are supplying the water to a nearby industry, because unplanned cities have industries also inside the cities. But if you go to a planned cities, then you do not have industry inside the residential area, commercial area. So their pipeline system will never break. There will be no leakage because their pipelines will be smaller in size, diameter will be smaller. But if industries are integrated within the residential area in many cities, then you have to supply water in larger pipeline, because from the same pipeline industries are also taking the water, and various loopholes and disadvantages are there to put industries inside a city which are unplanned in India. So again, we are again working on that also, so that we will be going for smart cities. So that's why the smart cities concept were there. And right now also smart cities, again, in last few years it was stopped, but again last year they have proposed the smart cities, and this time also again various cities have participated in smart city kind of competition. So here you can see in the map that there is a leakage in the particular area, and if you have the DEM data you have, which already you have, like you have land use, land cover, and all those that data, and once there is a leakage and you have the whole SCADA system, like data acquisition system, and you get a warning from that sensors you have connected, at the same time, if you open your GIS, ArcGIS integrated IPANET or water gems at the same time, then you fetch the real-time data and you can see the flow of water on that particular area, even if below the soil. Below the soil, it will be jet leakage. It's a very small burst, but there will be a jet of water coming out. So those kind of detection also you can detect instantaneously, and you can go for any kind of renovation or any kind of checking. So very useful. GIS is highly useful nowadays. In addition to that, mostly the GIS and the leakage detection sensors, non-revenue water control will be done in DMA. Those are district metered areas. Again, meter means just like your electrical meter, like you have a meter at your home, how much electricity you consume, you pay according to that. If you consume 0 to 100 units, then just as an example, you'll pay 4 rupees per unit. Once you exceed 100 up to 200, you will be paying again more than 4 rupees. Again, if you exceed 300, you'll pay more than that. So increasing. Similarly, district metered areas, people pay for water. If we permit it for 135 liter per capita per day, and you say that in your house you have 5 members, we have supplied you 500, approximately 800 liter of water per day, and if you are exceeding beyond that, you have to pay according to the meter. So those are again grading pattern which is implemented in India and also in many countries. In various countries, actually they have implemented this particular systems, and actually they have saved billions of rupees. Okay, in Russia also we have this particular system, and when they have implemented the integrated GIS smart water management system, they have saved gallons of water and billions of rupees. So if they were used or utilized $1 of money for saving specific amount of water, that amount of water actually costs about $5 rupees. So it's very highly useful in long term, even if our capital cost is high. And GIS integration is easy also. Like I have said, we have a SCADA system, and you do not need to create the system. SCADA system is again present, available for you. You just need to integrate the parts which you have taken as the important parts you consider. Okay. For me, again, I'll consider the land use, land cover also, industries area also, population, residential area also. And if I'm pumping water from 25 kilometers away, then that particular area also, because right now in Jalandhar we are pumping water from 28 kilometer. In between we have two pumping systems and two underground stories. So we are storing gallons of water. Literally think we are pumping from 28-kilometer distance. So see how much energy we are being utilizing, or we being utilized in this process. And if we waste water, then what will be the consequences in the upcoming days? So, as we are unable to create any kind of strict policies and rules for any kind of losses, non-revenue water means unbilled connections. So, we are planning to implement this DMA zones. So, we'll make DMA zones first. I have proposed a project recently to DST. So, we are trying to make a pilot study, like one zone of the Jalandhar will be DMA only. Okay, those zones which are considered as POS area. So, like ministers or good people, like above average income level people stay there, we will be implementing DMA on those area. Means we have to make the people agree also that we will be fetching your daily to daily data to implement this DMA. So once we implement the DMA, means we are implementing the GIS integrated smart water distribution network into it, and we are going to charge according to their use. So again, the charge will be in pilot study will be very, very less amount, like we are going to charge approximately 1.5 rupees per liter. So it's starting. Okay, so we are going to implement a pilot study. So those who are students can also work in this particular field, which is completely a new research nowadays. People are focusing, scientists are focusing. Okay, so you must work because natural resources, water, and very much required. Without water, we cannot even sustain one day. Without air, like not more than few seconds. Similarly, without water, we will not be able to sustain one day. So we need to do. In addition to that, we our asset management is also very, very much required, because you have invested the cost now. Not only pipelines, I have not given you the brief of, because of time I have not given you the brief of valves also. We have various developed valves nowadays present in the market, like pressure sensors. We have flow control valves, we have total control valves, we have pressure sustaining valves. And you'll not believe all these valves are available in the software. Whenever you are making any kind of pipelines, you'll put those valves. Pressure sustaining valve will be sustain the pressure means maintain the pressure. Okay, like water is coming to your home means you need a particular amount of water, at least 5 meter head. Pressure means again, let me correct myself. Pressure is not pressure. Pressure is not pressure in Newton per meter square. Pressure is pressure head, which you measure in manometer. If you have done the fluid mechanics laboratory or hydraulics laboratory, Then you have done the manometric experiments and you see the manometric lens, okay, that is H. That H is pressure head. That particular head, actually in conventional way we measure in the field through piezometer, which is your simplest form of manometer. You have studied it in fluid mechanics if you are second year and above that. So piezometer we use in conventional way and we measure the pressure head at each and every point of the pipelines before supplying it to you. So it's not a easy peasy work, water distribution. It's literally water supply engineers, they work on pressures to make your pressure perfect. Those kind of thing also we can do through pressure sensors nowadays, and those sensors will be again integrated with ML and integrated with GIS, so you will be at the real time will see how the pressure is fluctuating. So if any pressure fluctuation, again, if pressure fluctuation is high, then there will be any kind of non-revenue water, someone is taking the water in unbilled way, or there is some kind of leakage. So pressure detection is very much required and must be integrated with GIS. So again, how to check it? When we check this, we make a minimum night flow. We say it is MNF. Why? If I go for district metered area and demand driven model. So what is demand driven model? In the morning time you require more water, we will supply more water. In the daytime you require little bit lesser water, we will supply lesser water. In the night time you do not require water, still we will supply you 50% or 40% of water. That is demand driven model. So if we go for demand driven model, that means night time we are supplying you lesser water. At that time we will run the water because minimum night flow will be there, and at that time if we see any kind of leakage or any kind of unbilled water someone is taking, then we will be able to analyze it. And I'll show you one dashboard also if your team permits. That particular dashboard will be connected to customer and the administrator. Very small dashboard students have planned recently. So on that particular dashboard, we will send a message to that particular customer that at your area, at your home, maybe water is leaking. Check it. Otherwise, you are going to pay for it. So that particular dashboard will be very highly helpful, just like app, and they will get a message instantaneously in the pilot study we have planned. So yes, asset management also you can do all types of valve checking, any kind of sedimentation, whether water is flowing or not, everything you can check in addition to your life cycle cost assessment also. So again, another part in this particular water distribution network is life cycle assessment. So like you have studied in estimation and costing, if you are in civil engineering, estimation and costing is a very, very common subject and very important subject I consider, because nowadays civil engineers are like many contractors are there in the market, though those who do not require actually civil engineering degree, but they do not have idea about the surveying. First thing is surveying. They do not have idea about the critical things required in surveying, and another thing is estimation and costing of the project. They do not have idea. They can do any kind of building, but they do not have idea in this kind of things. So if you are a civil engineer, you must know about the life cycle assessment and estimation and costing in optimization way, in addition to surveying, which is a main part. So GIS is actually surveying, just like when there was no scientific calculator or no critical algorithms available, still there was calculator, and calculator was based on one algorithm. The algorithm is again focused on the fundamental mathematics kind of thing, and right now you are using it instantaneously by getting the data. Similarly, when you go for the GIS analysis, you need a lot of data, and the basic fundamental theme is surveying. So if you have idea about surveying, then you will be using GIS, and it will be seriously perfect integration. So you must have idea about survey. So if you are studying survey, then focus it rigorously, religiously. Okay, so right now I'll focus on the city which is in your state only, because I have taken Nagpur only. However, I have few data of Dharwad also. In few IITs also they have implemented the water distribution network inside the campus. So we can also implement, you can also implement inside your campus a small pilot study. Similarly, Dharwad area also they have implemented, and in Odisha also we have a town that is Puri. There also we have a pilot study of water distribution network integrated with GIS and this water distribution network, smart water distribution system. So in Nagpur also we have implemented, but see, Nagpur Municipal Corporation is integrated with PPP, which is your public-private partnership project. So again, government is also having the share of it, and public means public in terms of, like I have said you, if I implement a pilot study project, then I have to make the customer aware about the project, and they need to agree, they need to agree that they are going to pay the bill, okay, and they have to willingly participate in this particular project, then only we'll be able to fetch the data and we will be implemented in a higher scale, otherwise it's not possible. So similarly in Nagpur, Nagpur Municipal Corporation and public private partnership was done, and it's a government project, it's not a project by anyone, it's a government project, but public means customers were taken into account. We have various stakeholders, okay, customer is a bigger stakeholder here, then government, then those who will invest, okay, and those engineers, those who will be there, okay, like water supply engineer and all. Not only civil engineer, we will be having electrical engineer inside it, we will be having mechanical engineers inside it, we have others engineers also, like if you integrate AIML into it, you will integrate GIS, then we will be having GIS expert inside. So all are stakeholders, all are participating in this whole system. Similarly, if we have a SCADA system, we will be having core computer science people with us so that they will fetch the real-time data. Like in the second picture you are seeing, that is a Nagpur data only inside a Nagpur Municipal Corporation. They have a small office. Even if you are seeing the office is large, it's a very small office, and I have a video also of that particular office, and here you are seeing they are checking the pipeline network in the real time. So again, it is being implemented in already in India, and in the upcoming time I'm expecting in various cities, specifically those who are smart cities, it will be implemented. And the same is also discussed in G20 mate, okay, in the year 2022. It was already been discussed that we are going to implement it very soon. Just like your carbon credit, it's also very much important to save the natural resource. So what actually Nagpur 24/7 smart water supply project is doing, they are supplying 24/7. They are not going for intermittent supply. Okay, so I have not done a research on intermittent supply of Nagpur, but I think they are having intermittent supply twice or thrice a day. But this project to a specific area, to a DMA zone, supplying 24/7 water. But when they implemented this project of approximately 28.30 crore, what were the initial problems? The initial problems were still the NRW was around 60%. 60% is non-revenue water. Okay, where this water is going? In addition to leaking, various people will take the unbilled, unauthorized water. Okay, like in the slum area, water which are being supplied are unbilled. Similarly, the water which is connected to park area and you have opened it, you have left it, those are unauthorized and unbilled amount of money, water which people need to pay or municipality needs to pay. So those are all coming to NRW, which we need to check and to block it. Okay, whenever it is required, we will provide. Otherwise, it will be blocked. So those around 60%, when it was implemented within a month, the data is being taken and it was 60%. But when the GIS is integrated, the data were faced and various renovation work, various researchers and engineers have worked upon it, and it was reduced to 15%. Okay, so NRW is right now in Nagpur is 15% for this specific project, and let me say you, it is going on. Okay, so if you are again working on projects, then you can also take the data and you can simulate how this particular project is going on, and accordingly a similar kind of project you can design. Similarly, again, even if we are having this DMA zones, again, supply will be only for 4 to 8 hours. Why? Because this is a pilot project and the other parts of the Nagpur are on intermittent supply. Still today, they are on intermittent supply, and the specific DMA zones is only the zone where we need to supply 24/7 water. So earlier it was 4 to 8 hours per day. Why? We do not have a reservoir to take water. We are taking the water from the same reservoir, the reservoir which is supplying to other areas also. So right now, it was again reduced to this 4 to 8 hours is again now 24/7. So we are supplying 24/7 water, and the demand is being managed. The demand again will be given by you as input. We will say 135 liter per capita per day we are going to supply. You will say okay, at night time I require 30%, means 0.3. We will take, okay, at 1 to night 12 to night 3 up to 3 o'clock we will be supplying 30% of water. Those data again we have a dashboard where we will take it as multipliers value. And in the morning time you say, okay, at night time I have taken 0.3, means 30% I have taken, so at morning time I'll take 130%. So we'll say okay, but it should be within the range of pure amount of water, which is 135 liter per capita per day. If you are taking more than that, that's fine. You can take, but we are going to charge for it. Okay, same is again happening here. So here again it is 24/7 water supply, and earlier it was poor metering because it was not integrated with machine learning, looping pattern, nesting pattern, GIS. So now we are fetching it, fetching the data, real-time data, and also metering is also fine, means people are ready to pay. Similarly, earlier the capacity was higher. Even if we are supplying more water, bill was lesser because of leakage, because of non-revenue water, billing was less. Means, okay, I have given you 500 liter of water, but you are paying me for 100 liter of water only. That means in between we have losses. So that was happening in the initial problems, and again those were checked with mostly sensors, which was not available at the time during the 2019-2020 time. So this was again amended, and everything is being changed in the year 2022, and various pressure sensors were being utilized. In addition to that, we have again, you can see the picture, that system which you are seeing in front of the engineers, those are SCADA system. Okay, supervisory control and data acquisition. Supervisory control means it is like, if you have studied machine learning little bit, I know you are civil engineering students. In AI ML, if you have studied, you have a supervised learning and an unsupervised learning. So here we have a supervised learning. So this equipment or this whole system is not working on your own like AI. It will work whatever command we will give or whatever algorithm we will be giving. So those are supervisory control and data acquisition. So we are literally gathering years of data, and if this kind of system will be ready, we will be having 100 years of data altogether. We can simulate and we can show you how the use of water is increasing or decreasing. So literally it will be data storing kind of work is also going on, like government also stores data. So if you want to take the data of how water supply is happening in India and how much water we are consuming, wasting and all, you can also take the data from governmentdata.gov.in. We have a site where we take a lot of data, transportation data, population data, water data, and whatever data you require, you can fetch from this particular government site, very easily accessible, available to you, and you can start your work on this particular project, because initial data you require, what is happening in conventional form and what you need to change, you have to propose, so you can. In addition to that, in smart interventions along with GIS, we have installed the billing techniques. Like I have said, we have meters. Meter will be like, this is a meter, water is going from here and coming out from here. So meter will be in between. So whatever water will be coming to your house is coming like this and going like this. In between here, there is a meter measuring the volume of water. Okay, because pipe has a diameter, okay, isn't it? And it will be measuring this particular volume of water, and how much volume of water going through this particular meter is measured. So this meter should be perfect, no? Earlier it was faulty, so even if 100 liter is going on, it is giving me the data of 120 either or 60 either. So now these meters also available in the market, little bit costly, but again giving us exact data. So initial cost is obviously high. Similarly, right now, Nagpur is seriously taking the pipeline rehabilitation, renovation, checking of the sensors, flow meters, maintaining the pressures and all. Like I've said, pressure sustaining valve we have. So if you complain, like in my house, pressure is very low, we will check. We are supplying water to you, but in your house, water is lesser pressure and our sensors are also working, everything is working, no sedimentation. How it is possible? On those cases we will put a pressure sustaining valve in your area. Why it is happening? Because of friction. Like you have studied, if water is traveling a longer distance, energy will be lost in between because of the momentum will be lower down, velocity will be lower down, isn't it? So energy will be lost in between because of travel. Like I stay very near to the overhead tank. So in my area there is a park where we have overhead tank and stored water. So my house is very near to park within 100 meters. So I do not require any kind of pump. Water will come to my house and rise to the head top tank to up to the third floor. Why? Because pressure head is high at the time when you are very close. When it travels a longer distance, there will be loss of energy. So it happened with you. We analyze it and we'll put a pressure sustaining valve in your area. So it will sustain the pressure. So if you are supplying at a 5 meter head to that particular area, your house, because of installation of pressure sustaining valve, will reach to 5 meter head. All those data again you can face through GIS. So
Recording in
highly
progress.
GIS is required in this particular case. Okay, so I'll go into the Panet also, so that's why I'll close after this. So various advantages are there, which already we have discussed now. It will be scientific, it will be reduce your innovation cost, and you do not require the pumping house people. Like right now, if you analyze, if you observe, then you will be having a pump house in your area. 2, 3 people are working over there. If they didn't switch on, then water will not come to your house. So they have a pump main, they have a skilled main, they have 2, 3 unskilled main like laborers. So if something happens, they will rush and they will do it. Those kind of cost will also be reduced if we integrate with machine learning and GIS. So remotely we can control, or algorithm will control the pumping. But you have to control everything, like the tank in which you are storing the water, like your park wala tank. If water is below the initial level, then it will alarm. If it will alarm, means your pump will automatically switch on. Again water is filled. If again it reaches the maximum level, again it will alarm. So again pump will be closed. All these are again machine learning integrated. So those are the advantages. In addition to that, if we integrate GIS, you can face the real-time data, any kind of leaking, any kind of flow, any kind of elevation, everything. Non-revenue water loss, you can check. And limitations are obviously high cost, okay? And we require skilled manpower, like I have said, we require civil engineers, specific water supply engineer, specific water resources department dealing with this only whole SCADA system. So if we have a SCADA system, we need computer science people, electronics people with us, sometimes AI engineers also, and they will take care of the SCADA system so that a lot of skilled people required. In addition to that, data handling, storing data in cloud also require. So we require data storing devices. Means obviously, we will be having little bit higher cost. But again, on the other way, as I say, if we are saving $1 of expensing the $1 of money, then we are saving $45 of water. So software integration are complex again in the starting days, but gradually it will be okay if we first implement a pilot study and then implement it in a larger scale. So, okay, right now I'll show a very small simulation. No, I'll not show a simulation. Is it visible to you people? visible, ma'am?
Yes, yes, yes.
Ma'am, actually, I'm going one thing. I'm going to do one thing. I'm closing this presentation. It there is a self extraction
Huh?
installation program where you can install Ipanet 2.2, which is very small software, 3.5 MB only. Okay, once you install it, this kind of platform will open. Okay, this is a very small interface, and here you are seeing we have junctions, we have reservoir, we have tank, we have pipes, we have pump, valves, and everything. Okay, so this is a simulation interface. Now, what I'll do, I recently one of my student has done one system. Okay, so which I will show you for Jalandhar only. So you can see this is a system which is being integrated with GIS. So GIS data we have taken, and if I zoom it, you can see these are the pipelines here. Here, suppose here I'll zoom it. You can see we have pumps, we have tanks. These junctions are mostly the houses. So Jalandhar is unplanned. Okay. So at the same time, we are here pumping the water from the reservoir. So this is my reservoir area. But whether this system is working or not, obviously that's your obviously in your mind whether the system is working or not. Or let me show you how the system is working. I'm without okay right now I am mouse also. So I am right now what I'll do, I'll run it. So I have given all the data, whatever required. So I have simulated, you are seeing my simulation is done, run is successful. So what I have done a 168 hours of simulation on the right hand side. You can see means 7 hours, sorry, 7 day of simulation I have done. I have done a 7 days of simulation and my simulation is successful. Now you want to check the pressure. Okay, because pressure is very important. So here you can check the pressure so you can do. And now if I click zoom a bit, you can see all my areas are having good pressure. Okay, so okay, everything is fine. Now your simulation is done. So many times your simulation will not run. That means you have given the incorrect data to it. So how we give the data? If I click on one junction, you can see I have given the elevation, I have given the base demand, I have given a pattern also. So that is demand pattern. So if I go into pattern, I'll show you the patterns also. These are the demand patterns. So I have used demand patterns. Different demand patterns I have used for different areas. So literally I have 5 DMA zones, 5 district metered areas, and they are going to pay for it. So if I'm taking 135 liter per capita per day, then according to I have taken the multipliers for 24 hours. So this is a demand pattern for 24 hours. Okay, you can make it 24 hours. As I have done a 7 day of simulation, my demand is up to 168 hours. Okay, so you do not need to worry how to get the data. Again, we have an interface in which customer will put that within 24 hour at which time he is going to use more water and will modulate it according to his use. Okay, now if you want to check, okay, I'm supplying everything, but whether the water which I'm supplying is reaching to each and every house, how I can check it simultaneously at different points. So what I'll do, okay, I have taken pressure and I'll add different nodes. I have taken one node here. I have taken another node here. I have taken third node here. Okay, randomly 3 nodes I have taken. As per your requirement, you can take it and click OK. And now you can see the pressure variation. Okay, in few areas pressures are high because they are very near to tank. And in few areas pressures are approximately within a range of 40 to 50. Okay, fine. Even if it is 40 to 50, they are getting a high pressure water. Okay, similarly you can check contour maps and various other kind of maps also. Here you can see in addition to that, if you say okay, you have installed the pipes also, so what will be the losses in pipes? Means frictional losses. No, frictional losses if we check, then only we will be able to reduce the cost. Now, if we will be able to reduce the cost, means we are saving the energy, sustainable word will come here, and we will be saving the whole capital cost also. So on that case, I will be able to check the roughness. Okay, here it's made by the student for a particular competition. Here you can say roughness is very high, very high. Okay, roughness should be 0.005. What do you mean by roughness here? Roughness here high means there is a lot of sedimentation is happening inside this. So you have to reduce it anyway, or you have to design your pipelines accordingly. Okay, so again, if I go into the valve section, no, overview. Okay. Here you can see a valve present here. Okay. Here you can see a valve. Which valve is a pressure reducing valve? Why I have attached a pressure reducing valve? Because in this area maybe pressure is very high, which already you have seen. Pressure is very high. If pressure is high, there will be chances of burst. So we need to pressure reducing valve. We have to install. So we have reduced a pressure reducing valve. How much percentage of pressure it will reduce? 35% of pressure it will reduce. You need to put the data which are only in star mark. So it's a very uh, you know uh, helpful software and very easy to do also. In addition to that, I was saying you about the GIS integration also, but here the integration is through Google Earth Pro. Okay, so I don't think we have time to open it, but I think I have a backdrop file which is made in Google Earth Pro. Here we have not used GIS, but you can use GIS. So, okay, wait. This is a map. Okay, again, this map is not properly ordinates are not set. So here, if you go to the coordinate, you can set the coordinate. These coordinate data again you can fetch from GIS. Okay, you cannot fetch it by yourself. This will be fetched through GIS only, and GIS fetch data you are going to use it here. Okay, again for this we have specific formula to fetch. Okay, very easy formula, and your map will be set inside the EPANET platform, and easily you can put your nodes and junctions. So again, GIS, without GIS it's not possible to do this network and to run a, again I can backdrop it, to make a sustainable water distribution system. So those who are students, I'll suggest you must do this kind of analysis. Okay, it will be one extra addition to your CV that you are exporting EPANET and water gems you can write. In addition to EPANET, we have various developed software also nowadays. Easily available EPANET.js, which is highly integrated with Python language. So it's not like it's tool only, it is integrated with programming only. So if I show you this EPANET JS, for which we have also license. Okay, so see, we have all the road network which you can see easily. Okay, so here also you can draw all your networks, everything is available, and you can run and you can simulate, which is little bit online. Okay, but if you want to buy it, you can buy it also. Okay, so this is one online kind of tool for EPANET. So if you search for EPANET, you will know that it is highly advanced and utilized software throughout the world. So right now, I think we are about to 11. So if you will be having any questions, you can ask to me. I'm making it.
Thank you, ma'am, for introducing all these things to the participants. If anybody is having any questions, please go ahead.
Ma'am, there are some question in chat box. Snehal ma'am is asking about the. Please explain about the saline part.
I will take my question myself.
Yes.
Yeah.
Yes.
So, madam, it was a very excellent presentation, and that was very, very essential in today's time. And as you said, you get water from 20 kilometer. We get it from 200 kilometers and 120 kilometer even.
That's
Okay.
true. That's true.
Yeah, in Mumbai, because I'm sitting in Mumbai, and
Yes.
we get from 200 kilometers. Now, most of the pipelines are also rusted. This rusting is also adding to the contamination of the water, where we go
Yes.
with the chlorination and only sedimentation, which is not able to treat the water with that way. And another very, very important thing is about the saline water ingression, which is happening in the water sources. So from that point of view, I just wanted to hear from you regarding these two things, that how this contamination, because you spoke about the renovation aspect where we go for a change in the pipelines and all. So from
Yeah,
that
in
context.
terms of contamination, ma'am, which is on the way, We have specific tools to check it, but to reduce the contamination, I don't think I have worked in this field. I worked in water quality, but within the pipelines, when it is contaminated, we need to, whether we have to go for different kind of materials, like right now in India, mostly cast iron old pipes were used. Okay, so if we go for any other kind of material which is again will be able to reduce the contamination, then it's fine. Otherwise, if you say me, we want to check the contamination time to time so that we can take further steps. Those kind of water quality checking kind of things are also available in water gems and in IPANET. I have not shown you that part in IPANET, but again, water quality contamination checking part is also in IPANET. Again, how to reduce it is again a different research area, and mostly focused on which kind of pipe material we should take so that there will be no like infiltration of water into it. So either we will use different kind of concrete trench kind of things which will reduce the contamination or salination into it, or we have to go for a completely stainless steel pipes or PVC pipes, so contamination will be not inside. That will be again a different research topic for me, how to reduce the contamination inside the pipe. Mostly we will be focusing on to checking it, so that time to time checking and time to time renovation will be the focused work here in Ipanet and in Water James.
Fluid dynamics, because of which we do the pipeline laying with the fluid dynamics.
Mm.
So from,
Hydraulic gradient.
yes, from that point of view, I was just thinking that if that can be little explained, that with that fluid dynamics, how that can be mapped, and then accordingly the layout plan.
Yes, ma'am. That is also mapped in conventional water distribution system. We check the hydraulic gradient lines first, because if we check the hydraulic gradient line, flow will be proper. It's for the slope. For that, again, we go for the land elevations map. We take the land elevations map, and accordingly we lay the water pipelines so that there will be gravity flow. But if you are saying about the saline water, which is active for infiltration, is happened already, and the soil is already it's saline soil having high content of salts inside it, then it is very tough to whether we are maintaining the hydraulic gradient or not maintaining the hydraulic gradient. It's not possible to reduce the erosion or rust of it, because salt will be there, means there will be erosion of cast iron pipes or any kind of galvanized iron pipe, which is mostly used in India. If we go to another different kind of materials, which I suggest, that will be the solution. Hydraulic gradient is already maintained in all distribution network overally to reduce the energy part, so that there will be gravity flow and lesser energy will be utilized.
So how do we monitor the energy aspect? That because when I said that transportation from 120 kilometers away that we are doing, so how much Mumbai is losing on the revenue because of the transportation instead of creating their own
We can
water
monitor the,
footprint?
yes,
Yeah.
yes, yes, ma'am. We can monitor the energy for that. In specifically in these softwares, we have various kind of models. We have Hagen Williams model. We have Darcy Weisbach model. And for open channel like trench kind of storm water, if you are dealing with, we have J.G. Manning's model, which are actually analyzing the things on the basis of roughness. So more the roughness, more the energy calculation, more the energy will be lost, and accordingly you can do your energy calculation. So we will be focusing on the roughness and the friction part. So if more friction, more sedimentation, more energy is lost in between, we say it.
So if it is a far distance, then that would be generating a
More energy will
more
be lost.
energy.
For,
Okay.
for that again, we have scouring valves. We have various kind of sensors which will be detecting and giving us the data to maintain the pressure and energy accordingly. So for that, what we will do, we supply pipe water from different junctions. Means we make different junctions according to the demand, so that energy and pressure will be minimized. What I say earlier is, in the developed cities, in smart cities, we have different size of pipes. Usually the main pipe is having higher diameter, and the pipes which actually coming to our houses are lower diameter. So if the pipes are having lesser energy and lesser pressure distribution, then we have to manage the pipe diameter, and we have to focus the size of the main distribution pipelines also to that specific area. So
Yes.
pipe diameter is having another very important role, length and diameter.
Okay, my final question. Sorry for so many questions,
No, no,
but
no,
it
it's
is my
okay.
field experience which I'm bringing it to the table. Yeah. So
Yes.
last is about the theft of water directly from the source by the industries and others. Like the tankers and all, they just take it away and they sell it. So in this
Ma'am,
regard, because
yeah,
SCADA, when you said
non-revenue,
about the SCADA system, it is
got it,
already there
got
with
it.
the pollution control board and others are already implemented that in the
Yes,
area
yes,
it's
yes.
there, but still it's happening. Yeah, please go
Yes.
ahead.
Yeah, actually, one of the pilot study which I was discussing already implemented in part of Jalandhar. Actually, we have a MOU as PWSSB, which is Punjab Water Supply and Sewerage Board. So, along with that particular MOU, with the MOU, we have implemented one pilot study. So, we earlier it was NRW was 30%, and now we have reduced it to 15%. It should not be like we overestimate that it will be reduced to 0%. It cannot be reduced to 0%. We have reduced it to 15%, and those were again done because of the presence of sensors and checking of pressure fluctuations inside it. And mostly we have checked it because we have a night flow, the minimum night flow. During the night we run it, and we have checked like which industries, like most of the industries, they work more than the general residential houses. So during night time when we run it, we have, we find the data which kind of industries, like we have a sugar mill near to it, which runs during the night time also. So we face that that particular industry is actually using a lot of non-revenue water on the outside of the industry taps, okay, to cleaning the premises, to cleaning the pipelines, to clean the other parts of the machineries or areas. So they were using the non-revenue water which is not connected to the metering technique. So during the minimum night flow analysis we find them.
But that will be only when the pressure kind of a thing, when you said that fluctuation and then you are David.
Yes,
But I am
yes.
right now talking about directly taking it from the source. That means from the reservoir or the river, that which they are pumping out and using
No,
it.
no, 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 ma'am. No, that's not again under coming under the jurisdiction of municipality. Municipality, I think, is not liable to do that.
No, this is not about municipality, but in the rural region, what I'm talking about right now. In the rural regions, all the industries, most of the industries are set up in the remote areas and all.
Hmm.
And in
Hmm.
those places, like from the source itself, when the theft is. So,
Yeah,
about that, is there any studies or anything done or
no,
any
no, no,
way
no,
that
ma'am.
we
I
can
have not
monitor
studied it,
that?
but I think there will be specific policies and guidelines by the government, obviously, and all those kind of pumping are obviously illegal, and policies are there. So, if we go into the policy, I think we will obviously find it, the problem and the solution for it.
It's not. Thank you. Thank you very much for all the answers. Yeah.
Thank you, ma'am. Thank you. Thanks a lot.
Name of the site for the government.
Yeah, let me show you. Okay, I'm just sharing my screen for the last time.
Yeah, if you have any questions, then you can ask ma'am in chat. She can answer later because the next speaker has already joined. Yeah, yeah, please, ma'am, you can go ahead for next 5 minutes. No issue.
So, Radhika, you have the site in front of you, data.gov.in, okay, where you can find a lot of data. See, the data are discovered by Jal Jeevan Mission and a lot of sites. Okay, if you go into it, no, you'll find a lot of data. You just search it here, like here rainfall data is there. Okay, so I click on rainfall data. See, we have data is available, rainfall by district. Okay, various data are there. Whatever data you require, you have to sit for it and you have to find.
Great, thank you so much.